has a whole bunch of different stuff, but I just use it to capture. So I don't really like the program. Least common multiple and least common denominator. So we're finding the LCM. There are 3 different ways to do it. 2 of them are nice. 1 of them is just gross. Not to the visibility. No, we're doing study guide on Monday. Not to view gross, but just not pleasant. So the listing multiples. Listing multiples is one of the ones that I do like this one, but also I'm comfortable with my mathematical or my multiplication facts. Okay. So here's a hint right here. It's going to be easier for yourself if you just do the larger numbers first, because you might be able to see which one is going to be a multiple. Because the least common multiple, when I was a kid, I struggled with the concepts like, okay, why is something that says least, why is it bigger than greatest common factor, right? When you think great, don't you think big? But it's greatest common factor. Factors are small. Least common multiple. Multiples are big, right? Yes, they are big. It's you multiply just a 1-digit number, 8, another digit number, 8, you're already way up to 64, yeah.
So like the least common multiple is just small multiple, but the greatest common factor is a big factor.
Think of it like this. The biggest person on the Chinese gymnastics team, female gymnastics team, is probably going to be pretty small still compared to somebody else. Now, imagine the biggest person on the Chinese women's gymnastics team compared to the smallest person on the Rams. That's kind of what LCM and GCF are like. Okay? It's the greatest of the small, the greatest common factor, and the least common multiple. Here we go. 28, I'm going to be adding 2 less than 30, and 30 would be 58, sorry, 58, so that one's 56. I'm going to go ahead and zoom in. No. 56. Okay, I'm going to go 2 less than 30 more, so it's going to be 30 would be 86, but it's not 86, it's 84. Then I'm going to go 2 less than 30, which would be 114, so it's 112. And that's just 140. I'm going to stop there, because I really hope that it doesn't go that far with 12. That would be horrible. You're right on a flat surface. Handwriting is rough enough for most middle schoolers. You want to give yourself a flat surface, please. I'm not saying your handwriting is bad. I'm just saying middle school, you're trying to figure out dexterity. So this is just a multiple once again. So as it says right here, multiples. 24, 32. Nope. Let's try that again. 24, 36. Wow, it's been a long day. No, it's been a long day. 48, 60, 70, 72, 84. Okay, I had that installed the other day. It's whenever I'm doing an LCM, whenever I hit that multiple, that horrible noise happens. And if you aren't in class today and you just heard that through your headphones, I'm really sorry for breaking your monitor. Yes?
How are you putting the numbers?
As I just said, they're multiples of this. That's how I'm getting those numbers. So what this is it's actually 12 times 2, 12 times 3, 12 times 4, 12 times 5. Okay? But what I'm doing is I'm doing the way that you learned multiplication in 2nd grade, which is continuous addition. Continuous addition. Yeah? It is easy, and you could do it in your head, but the bottom line is if you make a simple mistake in your head repetitively, it can turn out like a couple people in this class who didn't get many right on today's homework because they were making the same mistake every time. And by a couple, I mean several. So we have the LCM of 12 and 28 is 84. Okay? Prime factorization. Prime factorization is my favorite way. Well, my second favorite way. My favorite way is the ladder, or the box or ladder method. For my second favorite way is the prime factorization. For LCM, this is by far my least favorite. If this works for you, yes, great, wonderful, grand. You have information on how to get it. However, let's see how this goes. I'll let you decide for yourself. No, I'm not going to use that color. 63. That comes out to be what? 7 and 9. 7 times 9 is 63. Okay, 7's already prime, so that's done. 9 comes out to be 3 and 3. So I'm going to rewrite this as right here by saying 63, the prime factorization is 3 times 3 times 9. It is 7. I did the same thing during fourth period. 3 times 3 times 7, fourth period. Then we have 105, and it's going to be 21 multiplied by 5. And that's just going to be 3 times 7. So I have 105. I'll put a line through here so nobody thinks I'm doing the same thing. 105, put them in order, 3, 5, 7. Okay, everything's going well. Everything is awesome. Now, everybody got that? As I do the I'm wearing glasses face. Write the prime factorizations with exponents. Yes, good. That means I have to write less. Beautiful. Okay, so I'm going to do 3 squared because that takes care of these two. I have 3 squared times 7. All right. So there's 63 again. And then I have 105. All right. Things are looking good. Things are looking good. 3, 5, 7. Good. Okay. Then the next sentence. Then multiply the largest powers of each base. Ooh. What do you think?
3 squared and 7.
3 squared and 7? Okay. Joe?
7 times 7.
Okay. Both the right ideas? No. Both wrong? Yeah.
We multiplied 3 by...
All right. What do you think you know? What do you think?
It's 9 times 7.
9 times 7? Nope. Here you go. A base is that number. The powers for 7 and 5 and 3, that's 3 to the power of 1. 3 times of something is, yeah. 3 to the first power is that number. So what they're actually wanting you to do is, whatever one of those has the highest, that's what you're going to multiply. So the 3's, this one has the highest power, right? 3 squared. So that's saying to this one, ignore that one. Then with the 7's, that has the highest power because it's the same thing. I mean, we're not going to make it that much bigger. Then we have 5 because there's no other 5, so that has to be the highest power. So now I have 3 squared times 7 times 5. So 9 times 7, which is 63, times 5 is equal to 5 times 6 is 30. 30 plus, or 300 plus 15 is 315. If that makes sense to you, your brain works in a different way than mine. It makes sense to me, but I don't like it. But if you use that one, that's fine, because on the test, you can use whatever you want to get to the correct answer as long as you can show you how to do it. Okay? How we doing? Okay. Yeah. Let's bring it back to Earth. Let's do the upside down division. Let's do the ladder method. Let's get something a little bit more comfortable. That's way too close. Way too close. There we go. So we're going to find the LCM of 40 and 56 by using the upside down division, aka ladder method. So we have 40. I'm going to use a different color. 40 and 56. And remember, we want to use only prime numbers on the outside of these ladders. Okay?
Good afternoon. I apologize for the interruption. 7th and 8th grade football practice for this evening has been canceled. Teachers, please allow students to make phone calls if they need to make other arrangements for transportation. Thank you.
So I do the quality of the field, maybe? I don't know. So then I take another prime number. I know that 2 goes in there. 14. Luckily, I have another 2. So it's 5. Prime number, so I know I'm done. Prime number, so I know I'm done. Can't go anymore with the ladder method as soon as I see one of the prime numbers. Or especially when there's 2 different prime numbers. Then it says to the right, multiply down the left side, left-hand side, and across the bottom. All the numbers on the outside. Here's where it differs from GCF. The greatest common factor, do you remember how we only used these numbers here? Greatest common factor, we only use those numbers, right? Now, we're using all of these here and multiplying those together. So here's the way to remember it. And for the students that were in my class earlier, I'm going to do the same animation. We have GCF, which is just the left side of the ladder, right? But with LCM, it's the left side and the whole bottom. No, yeah, somebody's coming in. It's like, can you get this? Oh. So I'm going to multiply all those numbers. Because remember, the least common multiple is like saying the smallest person or the smallest lineman on the Rams. 2 times 2 times 2 times 5 times 7. So we have 8 times 5 times 7, which is equal to 40 times 7, which is the same thing as 4 times 7 with a 0 on the end. So 28 with a 0 on the end. 280. Yeah. I can't imagine somebody as studious as you would shout out right answers unless the teacher's asking for it. Right? But yes, I did hear you say the correct answer before then, so good job. Last. Oh, those are all 3 methods. So, what time is it? No, look at all the examples. Look at all the examples. Yeah. So when you find the least common multiple, when you find the least common the least common denominator, you're actually really finding the least common multiple. So since it's the case, we need to rewrite 7/10 and 1/16 using their least common denominator because we're going to try to manipulate them. Not personally, but we're going to work with them. So we have 10 and 16, which is 2, 5, 8. We have a prime number. So now we need to go everything on the outside of the ladder. So we go 2 times 5, which is 10. 2 times 5 times 8. 2 times 5 times 8, which equals 80. So I have the new common denominator is 80. And remember, whenever you multiply the denominator by, you must multiply the numerator by. That's the same thing as we did never mind, that's accelerated. We haven't done that yet. You have to keep it equivalent. The same way that we did last year with the equivalent fractions, we have to keep it equivalent. So what's happening to 10 to become 80? It's being multiplied by 8. So we have to multiply this by 8 as well, which is 56. This is being multiplied by 16 times 5 is 80. So 1 times 5 is 5. And we're done with that one. Now in this situation, whenever you have 3, you can still use upside down division to do it with 3. You just have to have a common factor. You just have to have a common factor. So I'm going to take 12, 16, 24, hike, take a 2 out. 6, 8, 12. There's something else that can go into all 3 of those, Mr. Sparrow?
3, 4,
2. Yes. You're jumping ahead of yourself there. Okay, and there's nothing that goes in all 3 of those, so I'm done. So now I have to do what? Is it just the left side?
No,
all of them. All of the L. Ooh, I forgot about this one. Guys, a trick. What shape does this kind of make?
L.
It kind of makes an L. LCM, I forgot about that one. That's right. Yeah, so that L is the way to remember. Yes. That L is a way for you to remember that it's LCM. Thank you. So I do 2 times 3 times 4 times 6, which is going to be 4 times 4, which is 16, times 3 times 6. So 6 times 6 is 36. 36 plus 60 is 96 times 3. Hmm. 9 times 3, 27, 288. So between those 3, it's 288. Yes. I'm going to pass out the homework because we only have 3 minutes left. I'm going to be working on the examples here. So listen carefully. I'm going to be working on the examples up here, and you will want to look at these examples before you try to do the homework. Okay? If you don't have internet access, then see if activity, to do what you can and see if activity you can look at the examples of what we're doing. Make sure you're looking at your notes when you complete these. And okay, it says find the least common multiple by listing the multiples of each. Hello, sir. How you doing? Here, do you want? Tell you what, I'm going to give you this. Then you have some of them. You didn't get the homework? I guarantee you that there's 2 sitting somewhere. Who sits to your left? Who keeps messing up that homework? Here. Who sits to your left? Because that means that's the person that's keeping it from me. Yeah. I sure did. Appreciate you looking out. The what?
First side of the test. Tiger view.
I'm going to be grading it. It'll be on Sunday night.
Okay.
Yep. Mm-hmm. Have a wonderful night. Can you close that door behind you, please? Yeah, thank you. All right, so I got 15. The factors are 5 and 3. For 12, the factors are, I'm going to do it do exponents, so exponential form, and 3. So I'm going to multiply 2 squared because that's the highest exponent, 3 because I only need to do one of them, and 5. So I have 4 times 3, which is 12, times 5, which is 60. Let's see here. This is 4, 7. Okay, so 60. Now we get into the ones with the variables. Now this one here, you just have to think, when we were doing the homework the other day, that it was a common variable, but this one is not something in common, it's being multiplied together. So I know that this guy and this guy are automatically going to be in the multiples together. So I'm going to just do the prime factorization. I have 2 times 4, and then 2 times 2. Then I have 2 times 5, and those two are already prime. So I have 8, which is going to be 2 cubed. Then I have 10, which is 2 times 5. So now I'm going to take the cubed and the 5, because I don't need to worry about the 2 by itself. So it's 2 cubed, which is going to be 8. So it equals 8. So 8 times 5 is going to be 40. So it's going to be 40 ty. Now it wants us to do examples with upside down division, also known as ladder method. So now I'm going to just take these. I can see that there's going to be an 11 coming from here. So I have 44, which becomes 4, 11, which is 11. 110, yeah, no, 10. Take 2, 2, 5. Now I multiply all the way through. 11 times 2 is 22, times 2 is 44. 44 times 5. In my head, I'm thinking to myself, 4 times 5 is 20. So it's going to be 200 plus 20. So that's 220. No variables, double checking, no negatives, good. 30Q. What time is it? Ooh, I got to get to practice. Same situation. I know that I'm going to have a Q and an n to the 5th in my solution, because if I'm going to be multiplying these together, that's how it's going to happen. But I will show you how to get there as well. I'm not going to ignore it like I did on the other one. So out of those ways, I know that 3 is going to go into it, and 10Q is going to be left over. 15 and 5 is going to be left over. Once again, another fraction, or another line. I can take a 5, so this is going to be 2Q, and 3n to the 5th. So now I'm going to multiply all these together. So I have 3 times 5, which is 15. 15 times 2q times 3n to the 5th. 15 times 2q is going to come out to be 30q times 3n to the 5th. 30 times 3 is 90, so it'll be 90q n to the 5th. I have to get to volleyball practice. I will finish the rest of them, and I will post it on my website for you guys to study so we can be very successful in our test that's coming up. So, was I recording? Good. So I'm going to finish these, look it up on my website, because you're responsible for it, and also I need you to know how to do ones. Like this here is on the homework that I don't think a lot of people remember, greater than or less than. Bye.